Resolve that issue.
Duplicating, I mean data validation.
Yeah, I mean you are seeing duplicates in your target table while
Okay.
doing the SED type 2. What will be your resolution for that?
Uh, yeah, so first I won't directly delete the duplicate records, then we'll analyze the way duplicate records are getting loaded. So my first step is to identify duplicate business keys using group by and having a star greater than one. Then I will check whether the duplicates already exist in the source during the staging or getting introduced during transformation. In one my I mean last second project, banking project, we found the duplicate customer records in Snowflake after investigation. Then we discovered the source system was resending the same file, and our load process was inserting records instead of performing a match based on a business key. So to fix, we modify the DBT incremental model to use proper unique key and match strategy, and we also added DBT unit test on a customer ID to catch duplicate before data reached to the mart layer. So after that, then additionally we implemented audit checks comparing source counts, target counts, as well as distinct business keys. And after deploying this fix, then identify the duplicate records. We are eliminating the data quality improved. So here, how to analyze, like check the source data for duplicates and checking stage tables and verify match conditions, and after that verify DBT unique key configuration and check if files are reprocessed, and review the streams task execution history and run the data quality validations.
Okay. Suppose I mean a Snowflake query is running for 4 hours. It has billions of records. Now, what will you do to backtrace it and optimize that query? What will be your process?
Yeah, in performance tuning in Snowflake, like different steps we have to follow in Snowflake environment. So first, if the warehouse first step is if the query performance is very low, then we will increase the warehouse size. Like warehouse sizes are increased from lower to higher, like x2 6x. Then like I found that target tables were being scanned because proper filters were not appeared and partition pruning was not happening. And I checked the execution plan and identify the expansive joins and uh, unnecessary data movements. So then we optimize the SQL filtering data early, like removing select star or replacing some distinct operations and ensuring joins were performed. So on indexed business keys, then we also converted full loads into the incremental loads using DBT incremental modes. Then additionally, we implemented clusters on frequently filter the columns and increase the warehouse size temporarily during the peak loads. So after optimizing the execution time, after optimizing the execution time reduced from 4 hours to around 35 minutes. So here my main approach is, then we will analyze the query history and query profile, execution time by step, and warehouse utilization. So these are the one step, and the second step is to check SQL statement, like instead of star, then we will use required columns only, and apply filters early and avoid unnecessary distincts and optimize join conditions. And for check data volume, the third step is check data volume like full load versus incremental load, and after that partition pruning and micro partition scanning. And so coming to the fourth step, then we will follow the Snowflake optimization, like adding the cluster keys and increase the warehouse size and auto suspend or auto resume, and materialize use if it is needed. So coming to the validation, compare before and after runtime, and check credit consumed and verify the data columns. Yeah. So I always follow the follow the sequence like query profile and SQL optimization and data pruning and incremental processing. So incremental processing and warehouse scaling. So simply increasing the warehouse is the last option, because it increase the cost, so without addressing the root cause.
Okay. Um, okay. Can you tell me what is the purpose of dynamic table and materialized view in Snowflake?
Dynamic table and materialized view. Yeah, so dynamic tables are newly introduced in Snowflake environment. So same like as dynamic tables or Snowflake are used to automatically maintain the transformer data without creating a complex ETL schedules. So in our project, we received customer transaction data continuously into the raw tables. We used streams, tasks, and merge statements to refresh the reporting tables. So later we implemented the dynamic tables, and where Snowflake automatically refreshed the transformer data whenever the source data is changed. So, for example, like stage table was built on the top of the raw table, and reporting table was built on top of the staging table. So, Snowflake automatically managed the refresh logic based on the target lag. Then we will configure like that only. So this reduce the operational overhead, because we no longer needed to manage the multiple tasks and scheduling dependencies. So when we use dynamic tables like incremental transformations, real-time reporting, and replace complex streams and task pipelines and data marts and aggregation layers. So coming to the materialized review are mainly used to for performance optimization. They store pre-compute query results physically. So when business users run reports, then Snowflake reads the pre-computed data instead of scanning large base tables. Yeah.
Okay. Can you share your screen and open a notepad or something?
Yeah. Where we can, there is doc option. My screen is visible, right?
Yeah.
Not bad. Okay.
Okay. So there is a orders table.
Orders table.
You have columns like order ID,
Just a minute. Just a minute. Orders table. Columns like
order ID,
order ID,
order date,
order date,
customer name,
customer name,
and amount.
amount.
Now I only want to see the latest order ID of each customer.
Latest order each customer. Yeah.
Okay.
Yeah. Here open bracket is there.
Hmm. Okay. And now there's the employees table. I want to fetch the fifth to most highest salary of a person.
Fifth most highest salary. I mean fifth highest salary.
Yeah.
Yeah.
Okay. So you have a table one,
Table one.
and the column name is called one.
Column
Below that, you have records like one, and one.
one. Okay.
And you have table two, and the column name is called two.
Just table two column. Okay.
And you have records like one,
One.
and then one.
One.
Yeah. So now, what will be the result of inner join for this one?
60 cards.
And left join?
60 cards.
Okay. What will happen if I do a union?
Union. Union. Because from the global tables. So union all keeps duplicates and union display the unique records only. The output like five records. One one one. One 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 one.
For the union.
Yeah.
Okay. Okay. Suppose, I mean, there is order date and there is order ID. Now, I want to find the person, I mean, who have consecutively ordered for 3 days.
I think just a minute. After union, it is showing only one record. Only one record.
Okay.
Only one record. Lots of duplicates are there now. So union it is display the only unique records, right? So it is showing only one record.
Okay. What will happen if I do a cross join?
Cross join 6 records.
Uh, Okay, I mean, I have the order ID and order date. Now I want only those order IDs who have consecutively logged in for 3 days.
Order ID and order date.
Yes. Now I need those persons who have consecutively logged in for 3 days. For example, I mean today is 22. So the person who has ordered like 20, 21, 22, all 3 days.
Yeah. Yes, Deepa.
Can you walk me through your query, like what will that row number do and the name tag which you have added will do?
Data connection.
Yeah, just walk me through your query, what exactly will it do?
Yeah. So we have to extract the, I mean, yeah. How can I say, like, this logic is that, like, what it will say, like, this logic is that consecutive dates will produce the same grouping key. When we subtract the row number from the date, then group and count the records. So if the count is three or more than that order ID, more than the order ID as, I mean, orders are consecutive days. So this is a classic gap. I mean, I typically solve it is using row number and date arithmetic because it is a scalable, it is just scales wills for large Snowflake tables and avoid complex cell joins.
Okay, you have written minus R, and so what exactly this data function will do over here?
Minus, yeah. So minus data means data day and minus R means row number, then order date. Yeah, this is for row number. So this gap is techniques used to identify the consecutive sequence of dates efficiently without self
No, I
joins.
want to know how exactly this works. I mean, can you elaborate with one example, like what will happen?
Oh yeah. So consecutive dates collapse into the same group now. So non-consecutive dates and non-consecutive dates generate the different group values. So and therefore won't be counted together, right? So on that time, the logic is called as a gap and isolated pattern. So row number increases by one for the each row.
Mm-hmm.
Each row and consecutive dates also increases by one day. When we use subtract the row number from the date, so all consecutive dates and collapse to the same value. Then we group by that value and count the records. If the count is three now, so it means the order appeared for the three consecutive dates. So yeah, so it is Iceland pattern.
Okay.
Gap and Iceland pattern. This logic is called as a gap and Iceland pattern.
Okay. So, do you perform data validations and everything? I mean, when you get the target table, so do you perform the QA from your end, or how exactly that is?
Yeah. We will do the some basic data validations, right? Yeah. So yeah.
Okay, so can you write a query? So I have a data in source table and a target table. Now I only want those records which are there in source table but not in target table.
Sorry. Your question is, I'm not.
I want to fetch only those records which are there in source table but not there in target table.
Source table, but not there in target table. Yeah. So let's start. ST means source table. Left to join target table. P dot yeah. By using left join, then we can achieve this one.
Okay.
Yeah, suppose the source has I will explain the scenario wise. So suppose source has 1 million records and target has 500 records less in the target table. So I would use a left join or except to identify the 500 missing records and investigate the whether they where these rejected records due to the data quality issues or transformation error or load failures. So for reconciliation, then I usually start the row count validation. If the count don't match, then we use left join or else except to identify the missing records. So once identifying these records, then we will analyze the ETL logics and reject the records and transformation logic to determine why those records did not reach into the target. So this type of validation we will do.
Okay. Suppose you are writing a DBT model. In that, what is the basic validation test cases you will write and how will you write? I mean, what file you will write those and validate it?
DBT validation. Yeah,
Yeah.
lots of validations are there in the DBT like unique validation. So unit test as well as normal test and accepted values, then relationship test and yeah. So this type of test available in the in DBT. So like not test, then for suppose customer ID should never be null. So like that not test we will follow the this not test. Then uh, whenever we develop the DBT model, then I don't write just SQL transformations. Then I was also create data quality test to ensure the data is reliable before it reach to the downstream consumers. So then I use write these validations in the schema.ml file associated with the models. So yeah.
Okay. So what is the use case of macros in DBT model?
Macros. Yeah, macros are the piece of the SQL code when the business logic is repeating for multiple multiple times, then we will create one macro, then use multiple times. So yes, I have to use macros extension to avoid the writing repeating SQL code. So for example, in one healthcare project now, so we have 20 plus source tables, and every table requires the standard audit columns like load date and created by and updated timestamp. So instead of that, then we writing the some case statement and logic repeatedly. Then we created the reusable macros. So for suppose like SQL of curly braces, percentile macro, customer status inside of bracket status percentile close macro. Then case when status equal to A, then it is active. Whether the status equal to I, then it is inactive, else unknown. Then and then close the macro, end macro.
Okay. Now, what is the use case of DBT snapshots?
DBT snapshots. Yeah, so DBT snapshots mainly used for, I mean, to maintain, historical data, maintain the historical data.
Okay. Yeah, I'm good with my questions. Do you have any questions from your end?
No, for snapshots, so yeah, we use a DBT snapshot to track historical changes in domain and dimension tables, which is essentially implemented the SED type 2. So yeah, in our project now, patient information such as address, phone number, insurance provider could change over time. So business wanted to know both the current value and historical values. So instead of writing this existing record, then we use it to DBT snapshot whenever it is in SED type.
Yeah. Okay. I mean, I have, that's all. I mean, those were my questions. Do you have any questions from your end?
Yes, Deepa. So this is what kind of project?
Yeah, so basically you will be working majorly on, I mean, we get the requirements from the customer. We have like different sources. And then we do the transformations in DBT, load the data, do the processing in Snowflake, and then create a visualization tool for that. So these are our day-to-day projects.
I mean, what are the technologies involved in this project? I mean, we need to learn any new technology.
Majorly, I mean AWS. I mean Airflow tags as well. We are using Atomic UC4 for the orchestration, and yeah, DBT and Snowflake is the major development.
Okay, so this project is related to which domain?
The domain, I mean, it is a very vast domain, very big domain. So we have retailers, parks, and a lot of things. So yeah, I mean, it has a various, numerous amounts of projects.
Okay. Yeah, thank you for your time. Nice talking to you.
Thank you.
Bye, Arun.
Thank you, everyone. Bye.
లాగౌట్ అయినా లాగౌట్ అయినావా లేదా
Close this.
కొంచెం ల్యాప్టాప్ సర్వీస్ చేసినట్టు కలిగిస్తాను కూర్చోదా నువ్వు అది ఏం చేయాలంటే ఏడబ్ల్యూఎస్ అకౌంట్ క్రియేట్ చేసుకో క్రెడిట్ కార్డ్ సో దానికి అకౌంట్ తోటి స్నోఫ్లేక్ స్టోరేజ్ ఇంటిగ్రేషన్ ఉంది కదా సో ఆ స్టోరేజ్ ఇంటిగ్రేషన్ ఒక సిఎస్ ఫైల్ తర్వాత ఒక జేసన్ ఫైల్ లోడ్ చేయి తర్వాత స్నో ఫైల్ తోటి లోడ్ చేయి
Auto debit to choose one.
నేను నోట్స్ ఉంది కదా నోట్స్ దాంట్లో చూడు కొత్త స్టెప్స్ ఉంటాయి మన దీంట్లో చూద్దాం ల్యాప్టాప్ అక్కడ ఉంది తీసుకుని వస్తాం
ఓకే ఇంకా క్లియర్ అవ్వదు
అవన్నీ ఉంటావు కదా చేతులు ఉంటావు కదా ఒక అతనికి ఇంటర్వ్యూ ఉంటాయి 2 o'clock పవన్ అనే అబ్బాయికి ఇంటర్వ్యూ ఉంటాయి క్రెడిట్ కార్డు ₹2 కట్టాలి ₹2 వేరే తరగతి యూజ్ చేయాలి 30 పబ్లిక్ వేరే పడతాయి చేయి